All right, we're gonna do the radicals section. Just gonna go slide by slide here. All right, so the module is intended. So let's go with this one. When you have something like this, you will be just multiplying this. So it'll be 5 to the second power times 3. So that'll be 5 to the 6th power here. Okay. The next problem right here, just converting into a fractional exponent right here. So it's in radical form, so it'll be x 4 over 3 power here. All right, so the 4 stays with the variable, and then the 3 comes over here. So pretty much the 3 is the number in front of the radical. Okay. All right, so it's 4 over 3. All right. So it says evaluate right here, and whenever you have parentheses, an exponent outside the parentheses, you multiply them, so it ends up being x to the 4 over 3 times 5 over 2. When you do this, you could just straight up multiply x is x to the 20th power, 20 over 6 power, which is x to the 10 over 3 power. All right, and if you need to convert that into a radical, this will be 3 and then x to the 10th power. All right, this could also be, if you could keep extending it, if you divide this by 3, there are 3 of them that could come out, and there is 1 that could stay in. So that's also, these are all equivalent to one another. Okay, so x cubed, cube root x, right? This one, right? We have a negative exponent. Remember, a negative exponent doesn't mean that the whole number becomes negative. It just means that it goes to the denominator. So this is b over b to the 4th power. Okay, to the 1/6. You could also just do b1 plus -4. You could also do that. This is b to the -3 power. That ends up being 1 over b cubed. All right. Now that we've done this middle part right here, so this, if you cancel this out, again, that's also 1 over b cubed, right? And then you have the 1/6 power. And so you multiply the 1/6 power, you make it to both the top and the bottom. So this is equal to b, so 1 anything to any power from 1 to any power is just 1 over b to the 1/2 power. This is also equivalent to 1 over the square root of b. All right. Next problem here. Just go along here. If the negative exponent is in a denominator, you can just move it back to the numerator and it'll turn positive. So it'll be 3x to the 2 over 5 power. And then you do pretty much, you distribute the I don't want to say distribute, but you pretty much put the 2/5 to the 3 and to the x. So this is what this is what 5th root of 9, and this is the 5th root of x squared. You put this together, it'll be the 5th root of 9x squared. Okay. Express this in simplest radical form. The 1/2 power means that the 45, and so the 1 stays with the 45, and the 2 goes to the square root. Remember, there's an invisible 2 right here. So you just pretty much simplify the square root of 45. You split this up to 9 and 5. You split this up into 3 and 3. There's 2 3s right here, right? This is the prime factorization method. So you take out the 3 because you have a pair, and then it'd be 3 radical 5. Okay. With this, pretty much, again, you're bringing the 2/3 to each of these terms. So it'll be 8 to the 2/3 power. I'm gonna move this down. So it'll be x to the 12th power, y to the 24 times 2/3. And this, I have to multiply this by 2/3 as well. So when I do 8 to the 2/3 power, that is the cube root of 8 squared, right? I could just multiply these out here. That would be y, I could cancel this out. So that'll be 8, so that'll be 16. All over, I can multiply these out, so it'll be 4. So it'll be x to the 8th power. Go from there, then it's what? The cube root of 64. Y16 over x8. And that's equals the cube root of 60, that's 4. So the answer is 4 y16 over x to the 8th power. Express this in simplest radical form. Well, if you split this up, radical 13 and then radical x squared. Can't really do anything with radical 13, but you could, this cancels out, right? This is x 2/2. You put it into a fraction. X 2/2 is just x to the first power. And so you bring the x to the first power out, and then the 13 stays inside. Now things are getting a little more complicated. We have 7xy squared in the outside. We have the radical 175x5 y4. The inside of the radical. Let's focus on this portion right here. Let's separate this out. 175 square root of x to the 5th square root of y to the 4th. So 175, it's 25 and what, 7? And we don't have to do the GCF method because this is the perfect square method. So if we square root both, this is just 5 radical 7. Because the square root of 25 is 5, and we can't do anything with the square root of 7. Here we have 5 x's here. Look for the pairs. Again, I'm doing both methods. I'm doing the GCF method or the perfect square method, but here groups of 2, here's one group of 2, here's another group of 2. This is left inside, so it'll be x squared radical x. So the 2 become 1, go outside the radical. The 2 become 1, go outside the radical. So we have 2 of those. That's why it's x squared. And then the one that's left over is just x. Here we have 4 y's. We have 2 pairs of them because, again, it's a square root. It's a 2, right? So it is y squared. You could also just do y to the 4th power over 2, which is y squared. You combine this all together. You leave the outside, you leave the numbers outside. Or sorry, you combine those numbers that are outside, so it'd be what? 5x squared y squared radical 7x. All right. Next problem. All right. Something similar to what we just did, but now we have the cube root of that. So it is, oh, you know what? I forgot to do this. I forgot to, in the last problem, I forgot to multiply the 7xy to the 5x squared y squared. So it ends up being 35x cubed y to the 4th power radical 7x. Okay, so there's that. Hope I did everything correct there. Yeah. Okay. All right, this one is 54x cubed y to the 10th power. So let's focus on this, and then we'll bring down the 8. All right. So the cube root of 54, the cube root of x cubed, the cube root of y to the 10th power. This is, I guess, 27 and 2. This is 9 and 3. I'm going to use the factoring method here, and then this is the 3 and 3. Notice that we have a triple of 3s right here. So that comes out, okay, that comes out, so that's 1, 3. What's left inside is just this 2. Here, if you put this into a fractional exponent, it's just 3 over 3. So that's just x. Here, if I put this into a fractional exponent, we're going to have a remainder, right? The remainder, so it'll be 10 over 3. This, you put into a mixed number is 3 and 1/3. So focus on this is equal to y to the 3rd power and y to the 1/3 power. I don't know why it's not going. Y to the 1/3 power. So if we have y to the 1/3 power, so this is y cubed, and the 1/3 power is the cube root of y. We combine this all together, it will be 3xy cubed, cube root of 2y. And then let's not forget about the 8. So multiply the 8 times the 3. So that'll be 24xy cubed, cube root 2y. Final answer here. Here, you could just straight up multiply both the 4 and the 80. 4v7, 80v5 to the power 5. You can multiply them because you have a cube root. So let's do that. So it'll be the cube root of what? 320 v to the 12th power. Okay. So when you do that, let's separate them out. The cube root of 320, the cube root of v to the 12th. I think that's a v. Could be a u, but I think it's a v. And then this is 10 times 32, 5 and 2, 16 and 2, 8 and 2, 4 and 2. There's a lot of 2s here, 2 and 2. So remember, you have to get triples on this because this is a cube root. So there's 1, 2, 3. That's 1, 2. 1, 2, 3. That's another 2. And then the 5 is what's left over. Okay, so this is equal to 4 cube root 5. And then here is simply just 12 divided by 3, which is v to the 4th power. You combine this and this, the final answer is 4v4 radical 5. Okay. Next, simplify completely. You kind of ignore this a little bit. This is just kind of stating that x can't be a negative number. I mean, it's important, but just pretty much directly solve this out. So it'll be radical 4 radical x to the 16th power. This is 2x to the 8th power. Do something like this, which your statement is equivalent. Remember, this is x to the 21 over 8 power. There's no other way of doing that. So what you have to do is you have to make this into a mixed number, which is 8x to the 2 and 5/8 power. Right, so it'll be x squared, and then separate them out. So it'll be x squared, and then to the 8th root of x to the 5th power. So it will be this right here. In this case here, you don't have alike radicals here, but you can convert these into a fraction. So this is what, 8 and to the 1/3 power, x to the 6/3 power, and then this is what, 81 to the 1/4 power, x to the 12/4 power. This is the cube root of 8, which is 2. This is x squared. This is the 4th root of 81, which I believe is 3. And this is x to the 3rd power, because 12/4 is 3. You combine this together, that'll be 6x to the 5th power. All right. Next problem. Oh, actually, this is a good chart for you to learn. And these are all the rules that we've been applying over the course of the problems, and just look over this. And again, if you have any questions, let me know. But these are all the laws that we are applying for these problems. Okay. And something like this, we have negative x, radical 147. Let's split this up here. This is 49 and 3. Again, we can use a perfect square method. If you find a perfect square that divides into a number, you can easily just split this up. So radical, both sides, that'll be 7 radical 3. With this negative x, this becomes negative 7x radical 3. And then with the 108 x squared, radical 108, radical x squared. Radical 108 is what, 54 and 2, 9 and 6, 3, 3, 3, 2. So get a pair, because again, it's a square root. There's a 2 right there. So you're getting pairs this time, not triples. So there's a pair of 3s, there's a pair of 2s, and what's left inside is the 3 inside. So this is 6 radical 3. This is equal to just x. So it will be x times this, which ends up being 6x radical 3. So you have the negative 7x radical 3 minus the 6x radical 3. That equals to negative 13x radical 3. Okay. Moving along. You have radicals on the top and bottom. Usually you rationalize the denominator, but in this case, because there's a radical on the top and bottom, you could just divide them out. So you could, this is just 27 radical 27. And then when you divide x with the exponents, the variable with the exponents, you just subtract the exponents, so it'll be x squared. This ends up being radical 27 is 9 and 3. This is a perfect square, so radicalize both. Be 3 radical 3. Radical x squared is just x. The final answer is 3x radical 3. Okay. Here we're just FOILing. All right, so this is what, 5 times 5 is 25. 5 times b plus 5 radical 2 plus 5 radical 2 plus radical 4. This is 25 plus 10 radical 2 plus 2. Final answer is 27 plus 10 radical 2. FOIL this out here. Negative 16 plus 4 radical 6 plus 8 radical 54 minus 2, and then 2 times 54 times 54 times 6. Let me do that real quickly. 324. Radical 324. Okay. 4 times negative 16, 4 radical 6, 8 radical, and then, yeah, okay, and then let's simplify these. So negative 16 plus 4 radical 6. Let's simplify this. This is 9 and 6. So plus, this is 8 times 3 times radical 6. And so that's 24 radical 6. And then this is, let's split this up. It's what, 54 and 6. And this is 9 and 6. This is what, 3 and 3. And this is, there's a pair of 6s here. And it's a perfect square of 6 times 3. So it'll be 18 squared. Let me double check. Okay, so this is 18. So it'll be negative 2 times 18 because 18 squared is 324. You combine them together. So let me just write this out to kind of organize it. So this will be negative 52 plus 28 radical 6. And that's your answer. All right. Here again, you're just foiling. Like, make sure you foil. 3 plus x radical 3. 3 plus x radical 3. This will be 9 plus 3x radical 3 plus 3x radical 3 plus radical 9. 9 plus 6x radical 3 plus 3. Final answer is 12 plus 6x radical 3. Rationalize the denominator. You just multiply the top and bottom by radical 7. That equals 7 radical 7 over, this is radical 49. Radical 49 is 7. You cancel these out. This is equal to radical 7. Remember what I said about the cube? If I had a cube root of 7, right? You're not just multiplying both the top and the bottom by radical 7. You're multiplying the top and bottom by 49. Because what you want to do is you want to get perfect cubes. So 7 times 49 is 343. So it'll be 7 cube root radical 49 over, this is the cube root of 343, which is equal to 7. And then you just cancel them out. So just the cube root of 49. Just be careful with that when you rationalize the denominator. This is when you want to rationalize the denominator. So it'll be 3p cubed over radical 5p6. Now we know that this is a perfect square, so we could take that out. So it'll be 3p cubed over p to the 3rd power radical 5. And then we rationalize the radical 5 because we need to get rid of the radical in the denominator. So it'll be 3p cubed radical 5 over, this is 25, that's 5p cubed. Then we can get rid of the p cubed, so the final answer is 3 radical 5 over 5. This will be the last problem, but 5 to the 6 over 5 problem, sorry, 5 to the 6 over 5 power times 5 to the 4 over 5 power. Remember that you're adding the exponents. That equals 5 to the 10 over 5 power, which is 5 squared. See one more problem here. It'll be r to the 9/4 problem times r to the 8/3. This equals r to the 9/4 plus 8/3. 9/4 plus 8/3 is 12 and 12. So this will be 27. This will be 32, right? 4, yeah. So this will be 59/12. And that, so it's going to be r to the 59/12 power, which is r to the 4 and 11/12 power. Split this up, r4 times r to the 11/12 power, which is r4, 12th root of r to the 11. Okay. And that's it.